Alright, so we left off last time, way back when. Let's bring that up, take a look. Nope, still not right. So, did an in-class assignment. Oh, excuse me. Thank you. Yeah, let's take a look. I was here. Yeah, it was these questions, right?
Yeah.
Did anyone get an opportunity to actually write a modest amount of code to answer these? One? All right. Good. I appreciate the effort. We'll go ahead and what do I want to call these? Stream queues. 7 questions. Whoops, how did that go? So 2 of these aren't questions. All right, 5 questions.
That one I surmised it is an integer that denotes the position in a narrow string, CNCF, CRC log.
Data type designed to hold positions of string pointers / indices relative to the start of the stream. Type of the scientific data type.
I think I finished writing my answer.
All right. Yeah, I think that captures it. One is that it's a fancy name for integer. And excuse me. And that it is an index into a stream, and we're dealing with files, so a file stream relative to the start. How do you open up a file stream for reading and writing?
We do bitwise or with iOS : in, iOS : out. There's 2, the file name and then the second argument would be your flag. It's evaluation integer, so you're ORing 2-bit patterns. And
Wait, okay, so give me the flags.
in and out.
All right, everyone get the bit flag thing. If any of you are taking my, what number is it? 540. Yeah, systems programming. We deal with bit manipulation tremendously in that class. So you'll be ninjas, except instead of working nunchucks, you'll be working with bits. Yeah, I mean, yeah, absolutely. Wife from home. I have made accommodations like that. Like there's someone who had taken a class from me a few years ago who stayed in touch, and he had never had a chance to take the compilers class, so he'd been asking for some of my compilers materials, and I'd send them to him and answer his questions and stuff. So I mean, to the extent that you're motivated to play along at home, I'm motivated to keep feeding you info. All right.
Get versus put like that. One is you read, another one is write.
So for number 2, my example had fs.open for the file fstream, and then had the name of the file, like you do there, and then had the in, out. Then it also had app.
Yeah, do you know what that flag means?
I'd have to look it back up.
It's for if you're writing apps. No, it's
Oh,
it's
right.
append. It's append.
You're
Yeah.
writing iOS apps, right?
So this would, I would assume that this flag would, by default, when you open a file, the stream position is the beginning of the file. I assume that that then puts the initial position at the end of the file.
That ring a bell.
It's like in redirection, if you have just one, I don't know, less than sign, it overrides. If you have two, it's a 10.
Yep. So get versus put, read versus write, but get and read and write and put seem awfully similar.
I think that get and put are the names, the things, and tell versus seek, read or write, those are verbs. What you do with those.
Oh, nouns and verbs.
Yeah.
That's actually a good what is being done, or the action the function takes. I like that. Nouns.
The pointers.
The type of the thing being manipulated. How's that? Manipulated. Right. Yeah, I like the noun verb thing. Let's write some code to answer these last ones. So let me see. I can do that. I can make that a little smaller, can I? All right. So what do I want to call this? Hot and streamy. Go ahead and borrow get rid of one of those. Fstream, my stream, Stooge.text. And then I think what I will do is I will do a courtesy compile to make sure I don't have anything wrong here before continuing. Seems my upgrade didn't go according to plan. So I guess what I need to do is, where do I want to do this? All right, give me a minute. Let me Quit out of that. Quit out of that. Go up one. Whoops. Pipe that into SSH to 2266. I guess council.com. tar xf that. Put a V there. Make it look like it's doing something. It is. Yes, sir.
So that command, are you creating an tar file then sending it over SSH to remote?
To yeah, and then the extract command's running on the remote machine. The hyphen means having the file name as a hyphen means that it goes to standard out, and on the extract it means it's coming from standard in. And there we are. So I do that. I do.
So we are now in AWS.
No. We're now on a server that sits next to my desk at home. After the initial outlay, yes. Several years old. I bought it in 2012, maybe? The very end of 2011. Did have to replace the power supply on it. Alright, there we go. We're none the wiser. Everything's set up the way it was before. So here I had that open in Vim. Over here I had the questions. Over here I was compiling. Compiles without error, so we're still good. I guess I need to create a stooge.txt, so let me create that real quick. Okay. I guess we should do a modicum of error checking. Yes, sir.
So it will be correct to say this MyStream class, it has this conversion into bool operator. That's what gets called on line 8. Remember?
Right. The negation operator was overloaded on the fstream class, or probably a parent class.
In general, if we have like we can do while cin into a variable, it returns that object. So in general, if we want to have the object evaluate to a bool, we do a overloaded conversion operator, just as we did in the previous class.
Mm-hmm.
Is that the mechanism?
Yeah, it's just right. This right here is possible because somewhere there's probably something like bool operator fstream operator not.
Tell is the right and seek is the read.
So tell is the verb. So yes, let's clarify that.
You tell me what it is.
Yes, tell is the give me your current location. Seek is to change the current location. Tell me versus change me. And then seek is that terminology is coming from like hard disks, where a read-write head is seeking on the platter. All right, so we can, let's see, what did I got IO stream, so I think that error will go away now. No, doesn't like my, leave that there, just kicks. All right. So as soon as it opens the file, those pointers are at 0, which indicates that simply that our offsets. That's exactly what the stream position is it's an offset, right? It's from the beginning. So if you're at the beginning, the offset is 0. So it's just 0 counting like everything else in the language. So we're good there. Come up here. And we are asked to provide this. Tell G is giving us 0, and tell P is telling us 0, so that's the answer to that. After running fstream get, so help me call this function. So that will read a character, should get that uppercase L in Larry. And then we want to go ahead and, as it says in number 5 in the bottom left-hand corner of the screen, after we run get, let's find out what these are. So it turns out that the interface provided by fstream is a little bit misleading, because it is, for all intents and purposes, wanting to let us know that they differentiate between G and P, which means presumably when you're doing input, there is a get pointer that's, or offset or whatever you want to call it, that's being manipulated, and when you're putting or writing out to the file, there's a put stream position that's getting manipulated, when in fact under the hood there is only one pointer into the file, and the file stream class isn't making any effort to hide that from us. Now that goes down to the operating, let me say two things. It goes down to the operating system level, meaning that when you call the system's open command, right, there's going to be a pointer into that file, and it doesn't make any distinction between reading and writing. There's just simply an understanding where the current location is in that file. All the C++ architecture sitting on top could easily have provided two different pointers to us, but they didn't. They gave us the interface, if you will, and then didn't change a thing. So it feels a little gratuitous that they break these up into G and P. Nevertheless, we will try and stick with that semantic as we move forward. And this is when I was going to start drawing pictures, but I can't. So what I'm going to do is I'm going to grab, it's really going to steal the thunder, but I will grab an already drawn picture. Let's see, we're going to do this here. So here's the idea of what we want to do. This was developed over time in the original version of it, and things were added and changed. So what you're seeing is the finished product of this, really. But let me start you here. Is we want to look at a scenario where we have something like we want to replace, actually I don't want to use this at all. Let's use, yeah, let me just go over here. And we actually don't even need to go through the whole scenario. We want this idea of where we have a get pointer, and we have. What I'm gonna do is so that I don't have to manipulate this thing. I think that looks nice, but it's awkward for me to manipulate. So I'm just call that G. That's where it's currently pointing. So that's at offset 0 there, and there's one of these. So semantically, what we want to do is if we want to replace ABC with X, is we want get, right? These are gets. There's some algorithm happening here as it's potentially finding a match, but when it gets here, oh, actually I'm jumping ahead. It would be get. The 1 isn't part of our search. This is our search. This is our replace. The 1 doesn't match the search, so we read it in. Now we want to write it out. Read it in, write it out, read it in. That's the 3 that's just been read in. Write out the 3. And then we read in the A. Well, looks like we might have a match. Read in the B, read in the C. We do have a complete match. So now this one is going to write out an X. Right, and then it continues like that. So in our string substitution scenarios, these pointers, it is necessary for us to have these pointers separate, to have 2 separate pointers. So what we need to do is take this interface that we're given and layer on top of it. So what this diagram is showing is, let's go ahead and manually then, so the stream position is our type. We'll create 2 of these things, one for our getter and one for our putters. So this would be for the input and for the output. And starting here in the middle, you get a character, a 1 is returned, right? That's using this 1, 2, 3 scenario. So going all the way back to the beginning here, we got it, it's returned. And then if I jump down, we have an if statement in here. If there's a match, this would obviously be a variable, but hard coding, I've hard coded what was read in. If that's the first character of the search string, then we're going to do something. If it isn't, which is what we saw there for the 1, 2, 3, is it's just going to put that character back out. The problem, of course, is when you get the 1, in the absence of any other information, if we just go with what we're provided, since these pointers are one and the same, when I get the 1, if I then put the 1 is going to be put right there. Does this make sense? Given the code in the upper right-hand pane. I do a get, then I do a put, and right. That didn't match, so let's go ahead and put it back out. And I'm going to end up with what we see on line 30, which is we end up with 1, 1, 3, and we totally destroyed the 2. So we have to do a little bit of work to maintain the difference between these 2 pointers, and that's where this diagram comes in, the other parts of it, which is, so starting here, I do the get, it gives me the 1. before I do the put, I have this idea of these two variables. Before I do the put, I should do a seek p on this variable. So this starts out, probably don't have any editing capabilities on this. These both start out as 0. I do this get, and then before I do my put, I have to seek p this variable. Again, these start at 0. So that will then, what happens is I do a get. Now I do a seek p to whatever's in this variable. That's going to bring that back to 0. Now when I do the put, the 1 will be in the right place, and then this advances to right here. Okay? To make the whole picture complete, you basically have to take each put and each get, and you have to surround it with the seek statement. So whatever's in the get position, you seek that. That's going to move your one pointer wherever it belongs. You go ahead and do the get, and then you have to update that variable. So you do a tell g, and that's going to be a 1, and that's the new get position. So let me actually, let's illustrate that. Here's my get position variable. Here's my put position variable. They're both equal to 0. When I open the file, I do a, so again, the order is seek, one of those letters. It's the get or the put. I guess I should, let me use all right, that's my order that I'm going to do things. So, step 1, step 2, step 3, and these two, let me bring these two down here. Oops. All right, so first I do a seek g for get position. That's going to move the pointer to 0. Well, when you open the file, it's already at 0, so the net effect is it doesn't do anything, but it doesn't do any harm either. We do a seek g to 0. We do the get. That's going to, I guess what I need is a separate pointer. Here's the actual, here's the pointer. And then this g and this p will be these variables. So these are both at 0. I do the get, and then I do a tell g and assign that to get position. So tell g is now at position, these are the positions, 0, 1, 2, 3, 4, 5, 6, 7, 8. So you do tell g, it's at position 1. That gets assigned to this variable. Didn't match, so we need to do it. So this g got advanced with that. Now I do 1, 2, and 3 for the put. Seek p, that's at 0. That's going to move this back. We do the put. That puts the 1 out. Whoops. That puts the 1 out and moves that there. Then we do a tell p, and that's going to increase this variable. And so that allows us a separation. So this thing, as these get separated, at some point we end up with this kind of thing here. Then these variables end up being something like 6 and 3. And as long as we wrap our get and put around the seek and the tell, then what happens is our actual pointer just jumps back and forth between these two positions as it's writing and reading characters. Yes?
So get and put are abstractions that we create, or high-level abstractions, and those are the variables. That's something that we need to keep track of because there's only one read-write head internally.
Exactly. So so let's look at a possible design of how that might be. We can do seeker getter class thingy. Oops. We could do this. So this ends up being probably good to make the interface of these look the same. Now keep in mind that we've got a different kind of game going here, right? We're not, for the purposes of this class that I have here, I'm not going through the same rigmarole that I went through with, say, the stamping press project, which was we looked for protected variables and virtual functions to decide what we could inherit. I'm basically saying this class is just going to sit on top of fstream. If I don't define it, then it's going to run the fstream function. If I do define it, it's going to hide the fstream function. Where would it all break down and not be a good idea? If I create, say, a pointer to an fstream object and I put in the address of a seeker getter class thingy. But we're not doing that, right? And we're not dealing with the inheritance and the polymorphism here. We're just going to create a darn seeker getter class thingy object and work with it. We're not going to put it in the address of, or put its address into an fstream pointer.
Is that the reason why you don't use public for
Oh, I'm sorry. Do you have to do it this way? No. You know, some would argue that I'm being an ass and I shouldn't do that, in which case you can say fstream my private variable, and then you can work with it that way. I'm not hung up on that. The disadvantage to doing it this way is at this moment in time, all I need to do is basically put wrappers around the get and put. And if I go with this version here, I create two different versions of the functions I need to manipulate, and then the other 99% of the fstream class I can go ahead and use as is. The minute I decide to go with this way of doing it, making it a private variable, now if there's anything in the fstream class that I want to use, I'm going to have to create a public version of it here.
What will have to be that in your interface?
Are you mocking my variable names? Yes.
Same idea as the deck wrapper class. Deck wrapper class.
I have no idea what you're talking about, but I'll just say yes and nod. Oh yeah, the crapper class. We all know about the crapper class.
No, I meant the deck wrapper class.
The wrapper class. I thought you said crapper class. Right? That is just all right. That's going with it. Yeah. It's just exactly. It's a wrapper class. Thank you. I apologize. I interpreted it as something different.
Well, at least you didn't compile it as something different.
Yes, I guess that's good that I didn't. All right. I want these interfaces to look the same as they look in fstream. So what I'm going to do is I'm going to say fstream get. Oops. Fstream get. Let's look at fstream. Here's get, and it returns an iStream reference, and get takes a character reference. So I would say iStream reference, get character reference, and then I can go ahead and look at the OStream version for put, and I'm sure what we're going to see is that it's an O-stream reference, and note that it's not a character reference going in. Why is there not a character reference and just a character for this?
Not modifying. You're not
Right, right. The member function put does not modify its argument, whereas the member function get does modify its argument. And the way that looks, we can go ahead and write a little bit of code here. This is the and this would then be let's see, it is hiding it, so I'd have to say the parent class name. Copy and paste here. This is CP. This is put. This is LP. This is the put position. Now, if I use this class instead of an F-stream class, I
But we use CP get put position.
yeah, this makes sense.
Looks clean.
Those look clean.
So with like the O-stream put,
Yes.
he creates this entry object and then checks to make sure it's good. And then inserts character into the stream buffer.
All that's happening with that call.
Ah,
And then I'm forgetting one thing. What do I have to return?
The host return itself.
Yeah. All right. So what I want to do then is I want to dedicate Wednesday to you all busting out into groups, and we have the three search and replace scenarios where they're the same size. The search is larger and the replace is larger. So those are our three scenarios we have to work with. So using, say, this class is just kind of baby steps as a starting point, and there may very well be more classes than that. Get into groups and give me a sequence diagram for each of these.
question.
Yes.
So in the instance of the replacement being smaller, does it only replace the A and then leaves the BC?
That's exactly right. So in using these two, I find the ABC, so I'm doing read, blah, 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 blah. And that, after that replacement, that's where everything is sitting. So I read in a 4. The 4 does not match the ABC, doesn't match the A in ABC. So you have to put it out, right? And then the 4 goes here, and then this increases, right? And remember, these two are these two variables right here. And those two variables are being updated because we're using these get and puts and are updating those variables.
So do you end up with a
Mm-hmm.
1, 2, 3, x 4, 5, 6, 5? 6?
4, 5, 6. That's what you end up with, and this is where I said that there's that truncate function that you have to call. There's nothing in the C++ language that will cut that off, so you have to rely on an operating system call, and then it would be basically wherever your putter, right? Your put position is where the input value to the truncate function, because it's after you put in the last thing. That's where you want to cut it off.
What's the approach to the match function that you're matching? Are you using maybe like a buffer loop?
Yeah, some people attack this by creating a state machine, and as soon as you potentially have a match, you go into a different state and you're looking to confirm that you have the match, right? You keep rolling, and then you have one of two possible outcomes: is either you end up with a complete match or you have a failed match. If it's a failed, so let's say you're reading in ABC and it was ABR, it would read the A, the B, the R. You have a mismatch, and now you've got to go back and put the A and the B back out. Yeah. And so that's precisely exactly the thing I want you to be scratching your head with on Wednesday as you look at these scenarios, and what classes might you have to do this, and what are the functions, right? I mean, I want you to make an attempt at an actual sequence diagram. And then what I'm going to do is I'm going to take pictures of them and put them on my computer and up here so we can talk about each one that you all come up with. Okay? All right, we will see you on Wednesday.